When working with computers, we often get confused. What does this do? What does this mean? How do I do it? In learning complex tasks, people normally use manuals or expert teachers. We are all familiar with the standard interpreted computer language interface. A user looks up what they need to do, then types it in. Error messages are typed on the screen. The user fixes their work. Finally, the answer is typed on the console. The coach scenario offers an alternative to the type of interaction you just witnessed. A coach user is advised not by a manual or human interaction, but by an automated, adaptive help system. The user's errors and system help do not interfere with the user's input, nor does the computer output interfere with user input.
Hi, I'm Ted Selker at IBM T.J. Watson Research Center. For some years, I've been exploring the use of adaptive mechanisms in user interface scenarios. The Cognitive Adaptive Computer Help System, or COACH, uses artificial intelligence behind the scenes to provide user help text appropriate to situations. Let me show you how it works.
COACH provides personalized, automated help without intruding on the user's work. It allows either the user or the computer to initiate help in mixed initiative interactions. The system is designed to create a record of the user's experience and track their level of expertise in an adaptive user model. The user types into an Emacs-style editor window. The system never types in this window, nor does it ever stop the user from typing. Instead, as the user types, advisory help is given in help windows, directly above the input editor window. Computer output is presented adjacent the expression that produced it. The user can also use the mouse on help menu items to explore available functions.
This video will show you some of COACH's major features. We will also demonstrate how the COACH educational scenario can help solve problems encountered by the novice, the intermediate, and the expert Lisp programmer. We will take a brief tour of the underlying AI architecture, review the results from a COACH user productivity study, and conclude the videotape with some of the ways that COACH can be useful in other user interface situations. Let's begin by looking at user interactions with COACH.
Bill is taking his first programming course. He is sitting down for the first time in front of the COACH computer system. To help him get started, the help window encourages him to type a defined word or an open parentheses beginning an S expression, and also tells him how to get text editing help. Bill types open parentheses. Notice that help changes to advise him that he must type a function name. Function and symbol are examples of concepts in COACH's domain knowledge lattice. Bill now types AD. The help window tells him that no known function begins with AD. Help suggests that he correct his work. Bill could try pressing the mouse button to find available functions, but he recalls plus, not add, is a Lisp function, and enters it. As Bill types a space after plus, an example of using plus and a simplified description are presented on the help window. As Bill correctly makes repeated calculations using plus, help information tracks this and shows him the more sophisticated material on plus. Bill, temporarily getting confused, begins using names of items without first defining their variables. COACH decreases its perception of Bill and gives him more information help. COACH's context-dependent help allows novice users to avoid usual startup problems and avert mistakes that involve mixing syntax and ideas together. Harry is an intermediate programmer. Trying to write a program, he types open parentheses defun. COACH reminds him with syntax help that he must name a function being defined, then give it an argument list. The system gives him an abbreviated syntax and does not show him any of the difficult argument types, such as ampersand keyword and ampersand optional. Harry names the function ×2, gives it an argument, I, and starts typing the function plus. The system responds with help for the plus function. An example of the use of plus he has previously made is displayed. Harry realized that he didn't mean to add numbers, backspaces to retype times. The help system focuses on times as he finishes the times function. Then to defun, when Harry is done with the times function. To test his new function, Harry types times 2. Even the first time he uses his new function, Coach shows him that it needs one argument. He types 5, close parentheses. The system types 10 in the output window. The next time he tests the function, he tries using no argument. Instantly, the help window shows him his last success. Intermediate programmers often have problems keeping track of context and appropriateness of program pieces. Coach keeps these programmers oriented through context-sensitive help and user examples. Expert programmer Connie is working on an internal part of the Coach Update Rule computer program. The system is used to her expertise and presents very little help. When she types open parentheses defun, the system shows her terse, high-level help. If she uses a function send, for which no help has been written, Coach reaches into that function's system definition and presents an argument list. Connie can use Emacs editing commands to move around her code. Here, she puts an S expression into the cond statement. If Connie should make an error, the system signals it. If she continues making errors, Coach changes its opinion of her. Coach shows her more help. When Connie uses a function or a variable name which she has not yet defined, Coach puts these names on a list of undefined functions. A menu allows her to select these names to aid in defining them later. Here, stupid is retrieved from the undefined variable list. Experts are likely to use, even if they don't memorize, sophisticated syntax features. Coach shows experts the delicate, anomalous things about parts of Lisp without bothering them with introductory information.
The scenarios we have been exploring demonstrate several new user interface technologies: real-time adaptation, automated help selection, and automated augmentation of help information. Now that you are familiar with some of Coach's special features, let's take a brief tour of the underlying AI architecture which produces the Coach paradigm.
The Coach shell consists of 5 objects which interact to make the system. The Coach frame manages the editor, the menu, and screen real estate. It also dispatches input key and mouse events. An attribute grammar in Coach Reader and Coach Parser defines a domain, like Lisp, in tables and methods. Coach Reader handles token-level interpretation of what the user is typing. Coach Parser builds a model of the syntactic unit the user is typing. Both Coach Reader and the parser send Coach User information about the user. The Coach User relies on the production system to make decisions. The Coach PS production system uses rules to control help presentation and user model generation. The adaptive user model is a formal description of a user relative to a domain, which tracks change in the user's knowledge. The Coach's user model is explicit. It uses frames, facts, and rules to represent a model of the user and the skill domain a user is learning. A skill domain, like Lisp, for which Coach helps a user, is represented by syntactic and conceptual parts, tokens, forms, concepts, and basis sets. Adaptive user model frames exist for each of these things. They have slots which record aspects of the user experiences: goodness, worst, best, experience, slope, latency, and user examples. Coach records a user model frame for user-defined functions as they are created. This allows Coach to give user help for user functions. Coach's knowledge frames have the interrelationships between parts of a language and their relationships to underlying concepts. Coach has a simple, modular, and object-oriented design. It uses frames to represent a user and a domain. The language it coaches a user with, the way it presents data, and even the way it builds a user model are data, definable by courseware designers. 4 interacting strategies allow Coach to learn and to reason in real time. The frame-based knowledge domain is segmented. The lattice of relationships between Coach knowledge is explicit. Scalars are used for most user model characteristics. Reasoning knowledge is segmented into small structured rule sets. These strategies allow the simple forward-chaining rule system to run quickly.
To evaluate the Coach system, we ran a Lisp course usability study. The Coach adaptive user model was found to improve both perceived usability and actual performance when compared to the same window-based help system with non-adaptive user-requested help. During the study, users learned to write solutions for Lisp exercises with the assistance of a terse tutorial and the help system. Course material included complex data structures and recursion. Even though the pressure of learning Lisp in such a short time was frustrating, the goal of motivating users to use the help system to solve their problems was achieved. While large differences were found between the 2 user test groups, even the non-adaptive group performed well and believed their user interface was a significant improvement over the usual tools that are available. While the adaptive help group found all available help materials useful, the non-adaptive control group did not find the very same tutorial help messages valuable. We think this is a decrease in the motivation of the non-adaptive group and find it especially interesting given the fact that the self-perceptions of motivation between the groups is indistinguishable. The automated adaptive help group utilized all available materials, felt more comfortable with Lisp, and wrote 5 times more functions on average than the manual, non-adaptive Coach help group. The automatic adaptive help system succeeds in raising learning performance and productivity. Our user study demonstrates that an adaptive interface can improve user performance. Many interesting questions remain concerning user modeling approach and which presentation strategies help a user. The Coach system was designed as a tool for adaptive help research. By modifying rule sets, fine-grained studies of the efficacy for various help strategies are easy to arrange. By changing the lexical analysis table and creating a syntactic grammar, we have been able to modify Coach for use with other text-based interpreted interfaces. In this video, we have described the underlying Coach mechanisms. We have shown you Coach's major features and some examples of how Coach serves a variety of users. We have reviewed the Coach user interface study and discussed Coach's flexibility as a platform for research. We hope you can share our enthusiasm for the adaptive scenario to enhance interactive interfaces.